Types of media. So before we talked about that there were three different categories of media. We have copper, we have fiber optic, and wireless. Those are the three main categories we're going to use. Each of these categories is broken down into subcategories as well. And each subcategory has its own specifications and uses. For instance, a copper cable can be a cable TV cable that you use, or it can be a network cable, right? And each one is cabled differently, and each one has different requirements and specifications. So first we'll talk about coaxial cable, also known as coax cable. This is what you'd normally see on your cable TV. So your coax cable actually has two conductors that are composing it. You have your inner conductor and your outer conductor. Your inner conductor is insulated with a center wire that has the data that's passed through. So as you can see in the diagrams here, you have a center copper cable where the data is transferred, and then you have this insulation going around it. Outside of that, you'll have this braided shield of metal that helps protect the data transmission by keeping the signals inside the cable. So it will reduce your EMI. This is resistance to electromagnetic interference because of this metallic shielding, and that is provided by this outer conductor. So in high EMI environments, coaxial cable can be useful. Do we use coaxial cable for our networks much nowadays? Not really, with the exception of WAN links coming from your cable provider. So if you use Comcast or Time Warner, they use coax as a distribution method. Other than that, inside of our networks, we really don't use coax. And the reason is speed. Coaxial cables were used for a long time as 10-base-2 and 10-base-5 networks, which we'll talk about a little bit later, which was that old thick net and thin net for bus and ring networks. But they had a maximum speed of about 10 megabits per second. 10 megabits per second is definitely not fast enough for today's networking needs. Even a Cat5 network will beat that at 100. Cat6 and above is going to get you 1 gigabit or 1,000 megabits per second. It's just a lot faster, so that's why we've gone away from that. The other good thing about coaxial cable was you could do pretty long cable runs with this. It wasn't limited to the 100 meters, okay? Because again, you had that shielding, it allowed you to go further. Some different types of coaxial cables that we use. Three big types is RG6, RG58, and RG59. Notice it's RG for coaxial cables. For our Ethernet and our phone jacks, we use RJ, you'll see later. RG is commonly used by your local cable companies to connect your home. It's a much thicker cable with much more shielding. RG58 is what we used in our old 10-base-2 Ethernet networks. So again, it was a little thinner, easier to work with, and was used for internal wiring. RG59 is what you use from your cable box to your TV or your wall outlet to your TV. It's a thinner, more pliable coaxial cable used in internal environments and doesn't go nearly as far as an RG6 because RG6 has a lot more shielding. For the exam, what do you really need to know? If you see RG something, they're talking coax. Okay, that's about it, because that's all we use coax for these days. Another type of connector, there's two types of connectors we have on coax, okay? So those are the cable types, basically the thickness and the specification, but the end of them is going to be different depending on what you're using. The image on the top is what's called a BNC connector, usually termed as a bayonet kneel concealment. You'll also, in slang, hear it called a British naval connector, because they used it in a lot of their radios. This is what we use for 10-base-2 Ethernet networks. Basically, it has a push and twist type connector that you can see, but the inside of the cable is essentially the same. On your TVs at home and your cable modems, what you're using is actually going to be an F-type connector, which is a screw-on connector. And that's what you're seeing there in the bottom. It's a standard coax cable that you're probably familiar with from your house, that you've seen many times, I'm sure. The next type of cables that we have is what we call our twisted pair cables. Okay? This is the most popular LAN media that we use today, and it's called twisted pair. Basically, we have 8 individually insulated strands of copper wire inside of each single cable. So when I talk about the cable itself, I'm talking about everything connected, concealed inside this blue jacket. Each of these, there's 2 different wires here. There's blue and blue-white, orange and orange-white, green and green-white, brown and brown-white. Each of these is twisted together because that helps reduce the electromagnetic interference that is caused by the data traveling down the cable. The tighter the twist you have, the less EMI you're going to be experienced to. So one of the things you're going to notice if you ever take apart one of these cables, if you take an old Cat3 cable, the twists are very far apart. Maybe say 1 twist per inch. When you go to a Cat5, there's more twists, maybe 3 twists per inch. You go to a Cat6, it may be more twists, like 8 twists per inch. And so the more twisting you have, the less EMI, the faster data speeds and the further it'll go without interference. There's two types of twisted pair that we use, labeled as UTP or STP. UTP stands for unshielded twisted pair. STP is shielded twisted pair. The difference here is shielded twisted pair has a piece of metal foil inside of this plastic jacket to help shield it from outside EMI effects, from electromagnetic interference. And that's what it looks like here. You got STP at top and UTP on the bottom, and notice the foil is the only thing different about them. And of course, you can also see the top and the bottom. Notice how I talked about the amount of twists. Notice the top one has about twice as many twists as the one on the bottom one, right? Because here I have 2 twists in this span, and here I have 1, and starting the second one here. It's a longer span in between. Here I probably have 3 in the amount that's shown here with 2. Unshielded twisted pair, the number of twists determines how much the EMI can be blocked. Cat 6 has more twists than Cat 5 would. Higher categories have more twists. Twisting the wires helps insulate the wires themselves from the EMI by having that twist and bend based on the physical properties of the electromagnetics. UTP is cheaper than STP because there's no extra foil that's added to it. It's also the choice used in most wired LANs today, local area networks, because of the low cost and the ease of working with it. Shielded twisted pair, on the other hand, all those wires are still twisted in pairs, but they also are surrounded by that metal shielding, and that metal foil minimizes EMI. STP also tends to be a thicker cable, or at least shielding around it, the plastic jacket, so it's harder to work with than UTP is. And STP costs more because, again, you put more into it by putting the foil in there. Some twisted pair connectors. So just like we talked about with Coax, where we had the B and C and the F type, we have different connectors that can be used with twisted pair. There's 3 that we use. The most common is RJ45. RJ45 is what we use for our 8-pin connectors for Ethernet networks. So if you're using a Cat 3, Cat 5, Cat 5e, Cat 6, Cat 6a, Cat 7, they're all going to use RJ45. And what we're talking about there is that thick plastic phone jack looking thing, right? It's your standard network connection. Most Ethernet networks only use 4 of the 8 pins though. In fact, we'll talk about that when we get to the cabling standard, that there's only 4 cables that actually matter, or 4 of the strands that actually matter in there, but we still pin all 8 of them in there for future upgrades if needed. RJ11 is a 6-pin connector, and it is your standard old phone jack. In those, you're only using 2 or 4 pins of the connector. And it is most commonly found in telephone systems. Okay, that's where you're going to find it. DB9 is that D-shaped sub-miniature connector. It's the bottom left there that's being shown from a rollover cable, for instance, for a Cisco cable. It is used for asynchronous serial communications, and it is usually used for connecting external modems or in a Cisco environment for using your serial to RJ45 rollover cable that we use in Cisco networking. Those are the 3 types of cables. But again, the most common by far is that top one with the RJ45. And RJ, just for your own notification, stands for registered jack. So registered jack 45, registered jack 11. Again, if you see RJ, think about it from a networking standpoint. So our twisted pair cable, the throughput that we actually have for these is based off of what standard it is. And again, that's based on the number of twists and the frequencies that are being used. If we use category 3, we're only talking about 10 megabits per second. Category 5, 100 megabits per second. Category 5e, it was the enhanced category 5, so it can go up to 1,000 megabits per second or 1 gigabit per second. Cat 6 also did 1,000. Cat 6a was an enhancement, and Cat 7, both of those do 10,000 or 10 gigabits per second. What will you find in most networks nowadays? Most people are still installing Cat 5e. And the reason why is Cat 5e versus Cat 6, the cost is significantly different. About 3 times as much for the cable. So using a gigabit is still plenty fast. I'm building a new house. My whole house is being wired with Cat 5e. And 1 gigabit is plenty fast for our networks for today and for future growth. So it's good enough for us. If you're using a server room, you may find 6 or 7, or 6A or 7, because you may need that higher speed connection for backbone connections. But for end devices, Cat 5e or Cat 6 is fine.
Must be something.
Yep.
Sorry. Must be awesome wiring going in that house. It's got it. Good stuff. Technology.
We have quite a bit of wiring going into the house. But yeah, and the other thing on this slide is the maximum distance, if you notice, for all of them is 100 meters. So if you're dealing with copper cables, it's 100 meters. That is a hard limit. You cannot go past 100 meters without hitting an active device like a router, a switch, or an active repeater. Okay. Straight through and patch cables. So both ends of your cable have matching pin outs. So if you're using 568B standard, which is standard on both sides, you're going to end up having a straight through cable. Okay. This is the preferred standard for wiring in a building if no pre-existing pattern is already used. By default, you should use 568B because that way you're using the same thing everybody else is using. The benefit of that is that if Jennifer installs it and 3 years later we hire John to work on the network and he gets to the jack, he looks at it, he already knows what he's looking at, right? Can you put these pins in, as long as you put the matching pins on both sides, it doesn't matter your color scheme. So if you have your own color scheme in your head, that's fine, but by standard, we should be using the same, okay? Data terminating equipment, DTE to DCE. So data terminating equipment is something like a switch, a computer or a router, right? And a data communications equipment is something like a switch or a modem, okay? When you're connecting from two dissimilar devices, a computer to a switch, a router to a modem, you would use a straight through cable, okay? When you go past that, then you start getting into crossover cables. And that's where you have the A standard matching up to the B standard. What we did here is we are actually swapping pins 1 and 2 with pins 3 and 6, and pins 3 and 6 with pins 1 and 2, which is our transmits and our receives. By swapping those, it allows us to connect a computer to a computer or a switch to a switch. Okay? So if you have two of the same type of device, you have to use a crossover cable to switch that transmit and receive. The only thing that makes that different is if your switch has what's called MDIX, which is media detecting information exchange. It can detect it and it can swap it for you so you can still use a patch cable. But for the exam, unless you see something talking about MDIX, you're always going to need a crossover cable going switch to switch, router to router, computer to computer. If you have two of the same type of devices, if it's a DTE to DTE or DCE to DCE, you got to have the same. You got to have a crossover cable. So this is where I told you we would talk more about the wiring standard. So here is a very clear chart of what the wiring standards are. The way I like to memorize this, because I don't want to have to memorize 16 different line items, is I memorize the one on the left. And then I remember that 1, 2, 3, and 6 get swapped. Okay? So if you swap oranges for greens, and you swap your oranges for greens, you're good. Okay? And what I mean by that is if you start out and you go orange stripe orange, green stripe blue, blue stripe green, brown stripe brown, and I change my oranges for greens, my orange stripe becomes a green stripe. My orange becomes a green, right? And so if you do that, you'll have both standards memorized by doing one. If that doesn't make sense, memorize both of them. But that's what we're talking about. Because the orange and green is your transmits and receives. They're getting switched over. So on the left is my straight through cable. Both sides will be here. If I'm doing crossover, I do one to the other. And notice here my transmit becomes my receive. That's why we do the swap. Transmit to receive. Okay. Orange became green, orange became green, green became orange, green became orange. That's what I was talking about. So we have two types of cable that we use. One is called plenum, the other one is called non-plenum. Plenum is a special fire retardant outer insulator is put into the cable. This can be with STP or UTP, excuse me. And if you have plenum cable, it contains PVC or FEP to minimize dangerous fumes if it catches on fire. So if you're going to use something that you can't see, so I have cabling going through the walls or the ceilings or a raised floor, it should be plenum cable. This is a safety issue, and by most codes in most counties in most cities of the U.S. Non-plenum cable, on the other hand, is your normal UTP STP rated cable. It cannot be used in places you can't see it. So if I have a switch sitting here in the middle of the classroom and we run cable to it, we can use non-plenum. As soon as I start running that cable through the ceilings or the floor or through the walls, you have to use plenum cable by code. Okay? Because again, if the wall started catching on fire, we don't want noxious fumes to get in here and kill us. So using non-plenum, that would happen. Using plenum, that would not happen. Plenum is also a little bit more expensive than non-plenum cable. So if you're building a house and you're putting wiring in, make sure your guy is using plenum cable, right? Which he should, because the code inspectors will get him otherwise. Fiber optic. So the third type of cable, so we talked about coax, we talked about copper twisted pair, now we're talking about fiber optics. Fiber optic uses light from an LED or a laser to transmit information through a glass fiber. Okay? These are great because they are immune to EMI, because electromagnetic doesn't interfere with light. It only interferes with electronics, right? The nice thing about this is light is being used instead of electricity. It also gives you a far greater range. Fiber optic cables can go many, many miles. Okay? Depending on the type of cable will determine its distance. Some can go hundreds of yards, some can go many miles. Some can go thousands of miles. There's a greater distance carrying capacity for these fiber optic cables. If you guys remember, we talked about UTP and STP. The highest we had was Cat 7, which was 10 gigabits per second. Some of these cables can go in the 60 and 70 terabytes per second. Very, very, very fast. Okay? There's two types of fiber cables. We have multimode and single mode, and we're going to talk about those more in a second here. So multimode has a shorter distance than single mode. And the reason for that is it uses a larger core size. When I'm talking about the core size, I'm talking about how big around the fiber inside is that the light is going to travel on. So because the core size is bigger, light can travel in many different directions through it. And that will actually slow down, cause a shorter distance for this fiber. So if we look here, we have a laser here shining through this fiber. This is the fiber itself. I have three different paths, one going up this way and bouncing around, one going this way and bouncing around, and one going straight through. Because I have three paths going at the same time, I'm going to have a shorter distance allowed so that they will all get to the end around the same time, okay? Because they have more distance to cover. If I get too long, they'll get to the receiver at different times and cause errors and emissions, okay? Common uses for this is going from a router to a switch to a switch, or a server to a switch. And the reason why is we want to be able to cover more distance at a higher speed than we would with traditional copper cabling. The core size on a multimode fiber is 62.5 microns. Microns are pretty small, right? We're talking like human hair size here. So even at 62 microns, it's very, very tiny and hard to see, okay? When we get here to single mode fiber, we can cover a lot longer distances because the fiber itself is smaller. Instead of 62 microns, we're talking 10 microns. So this is significantly less than a human hair. Okay? It's a smaller core size, allows only a single mode of travel for the light source. Because it can go only a single way, we don't have to worry about multiple paths, and we can go further distances. So these can go many, many, many miles. Okay? If I wanted to connect, say, DC to Baltimore, I can use a fiber cable to do that, even though that's 20 or 30 miles away. Usually here we're going to be doing switches to switches and routers to switches. Why did we take away the servers this time? Because servers usually are going to be pretty close to a switch someplace, right? So we're going to use the fiber and multimode for the higher speed fiber aspect, not for the distance aspect. Switches and routers, we want to go single mode or multimode to cover that long distance at a high speed. So connector types. With fiber, there are 4 different connector types we have. We have SC, which is our subscriber connector. We have ST, which is our straight tip connector. We have our Lucent connector, which is LC, and our MTRJ, which is mechanical transfer registered jack. Okay. There are also some little code names that we like to call these, or pet names, I guess. So SC, we affectionately call it the stick and click, because you stick it in and you'll hear a click because it's almost like an Ethernet jack where it's got these little raised bumps here, so it actually clicks into place onto the switch. Okay. The ST, we like to call this the stick and twist, because like an old BNC connector, you stick it in and twist it to lock it in place. Okay. Sometimes this helps people remember what the ST versus SC is when they're looking at them. LC is actually going to have 2 fibers connected in one jack connector. And you can see it's got this little thumb clicker, and it's called Lucent because it was made by Lucent Technologies. No cute name for that, but that's what that one is. And the MTRJ, although it looks very similar to this LC, it's actually about half the size. This one connector is the same size, is actually smaller than this SC connector here. So the MTRJ, where we use that for, is for routers and switches. And so I like to think of MTRJ as routing with the R. And it's 2 fibers in one single cable, and they are very, very tiny, usually used from routers and switches to each other. So you can get more fibers in a smaller space. So oftentimes you'll see the MTRJ on one side and the SC or the ST on the other side. So going from the switch to a PC. So copper versus your fiber optics. Fiber optic has the advantage by having bigger bandwidths, much higher bandwidths. They can cover longer distances. There is no EMI issues to worry about, and there is better security. Copper, on the other hand, has some advantages too in that it's cheap. It's very, very cheap compared to a fiber optic cable. I was down at the computer store today, and a 6-foot LC to LC fiber cable was $30. A 6-foot Cat6 Ethernet cable was about $5. So it's about 6 times more for the same length of cable, right? It's easier to install. If you've ever built a cable, a network cable with fiber, it is a pain in the butt. If you've done it with copper, it's not too bad. It's also inexpensive tools. So if you want to get a complete set of tools to build a cable, you can buy for under $10 on Amazon a complete kit which has the wire stripper, a bag full of ends, of RJ45 ends, and a crimper to use for under $10. If you want to buy a similar kit for fiber, you're going to be spending about $200. Fiber kits are very expensive, and fibers themselves are very expensive, and they're harder to build. So copper has a UTP STP has many advantages over fiber optic. But fiber optic, because of those big bandwidths and longer distances, can be really useful when you're doing switch-to-switch and router-to-router configurations. So keep that in mind. Media converters. We mentioned this earlier, but here's what a media converter looks like. It's going to take one type of media and convert it to another. So for instance, on this bottom left corner, you can see we have a fiber connection to an Ethernet connection, to a UTP connection, right? What kind of connector does this look like to you guys? That's fiber. What kind of connection? ST, SC, LC, or MTRJ? ST, stick and twist, right? Over here, what does this look like? That's actually an SC. Yep. It is two. You actually use 2 cables to connect to it. Yep. So, but yeah, they look very close. But yeah, that is an SC, stick and click. So once it goes in there, it'll click in place. But again, all it's going to do is convert. Whatever comes in as light is going to get transmitted out electrically. Whatever comes in electrically is going to get transmitted out at light. So up here, I got kind of a basic what it might look like. I have a switch in one building and a switch in another. The switch is going to connect to the media converter. I can then use a mile-long fiber under the ground to another media converter, switch it back to a switch again, and now I'm back on my Cat5 network, right? And that way I can overcome that distance gap by using those media converters.
Out of curiosity, what's the real-life size of a
Real life size of a media converter, about the size of a pack of cigarettes. Yeah. So they're not that big. Yep. And they do have to have power though. So you do have to plug them into a wall. Okay. Examples of them. Yeah. So the question was, how big are they? They're about the size of a pack of cigarettes. Examples. They go from Ethernet to fiber optic to Ethernet. There are some that go from coax to fiber and fiber to coax. There are some for every media type you can think of. And those are the types of media.